let me resolve this. $300 milligrams Q12 or 350 milligrams Q12, right? So 300 milligrams Q12 is 600 milligrams per day divided by 24 hours. So 300 is, wait, I don't know if you can that go away a little bit? Well, is 25 milligrams per hour. And 350 divided by 24 is, that can't be right. 300 divided by 24, 12 and a half. What did I do? No, that's right. 600 divided by 24 is 25. Sorry, I'm getting all turned around here. Or 350 times 2 divided by 24 is 29.17 milligrams per hour. So what do we expect to see for our CSS average with each of those? Now that we know that our clearance is closer to 2 rather than 4 liters per hour. So CSS average is going to be equal to bioavailable dose rate, so 25 milligrams per hour divided by 2.27 liters per hour. So let's see, hours, milligrams per liter. Yep, that's what we want. So 25, and remember our bioavailability is 1. If it was anything but 1, we'd have to be doing that, taking care of that in our algebraic calculations as well. So if we give 25 milligrams per hour, we'll expect a concentration of 11 milligrams per liter about. And if we give 29.17 milligrams per hour divided by 2.27, we're going to expect about 12.85, so I'm going to say about 13 milligrams per liter. So let the team decide which one of those you're going to choose, either 300 milligrams Q12 or 350 Q12. But you can tell them at 300 milligrams Q12 they're going to have a CSS average of around 11, and at 350 it'll be around 13. Does everybody see how to do that? Good. Now, we didn't really need to figure out the clearance, although it is helpful to figure out the clearance because you can then figure out the half-life. We could have said, right, that CSS average is equal to bioavailable dose rate all over clearance, that if these two stay the same, if we have no reason to think that those will change, then CSS average and dose rate become proportional, don't they? So we could say at dose rate 1, we're going to get CSS average 1, and that should be equal to dose rate 2, as is to CSS average 2, right? So our dose rate 1, we gave what? 400 milligrams Q8, so that is 1200 milligrams per day, and our resulting CSS average was 22 milligrams per liter. This was given to us, right? And they were having toxic side effects, so that's too much. We know we have to give less, don't we? So what's our new dose rate going to be that we're going to suggest if we're shooting for a concentration of 12 milligrams per liter? So now we just set up a simple proportion, don't we? And I will tell you it will come out the same as when we did the other, but let's go ahead and do it. Or it should at least. So this new dose rate is the exact same as we had before, 654 milligrams per day. And again, if we divide that into 654 divided by 24, so it's about 27 milligrams per hour. So we're in the same pickle, right, as we were before, this recommends 327 milligrams Q12 hours. So again, we could go back in and decide if we want to give 300 or 350 every 12 hours. And another way you could do that is by now we use a proportion and say, okay, if we give 300 milligrams Q12, right? 300 times 2 divided by 24, that's 25. Well, let's just do it by day. This is in days. Whoops, this is in days, isn't it? Sorry, should have read my units. This is why units are important. So if we're giving 300 Q12, that's easy. We're going to give 600 milligrams Q day. And then we solve for our CSS average, don't we? So 600 times 22 divided by 1200. So X is 11 milligrams per liter, just what we got before. Right? So at 300 milligrams, we're going to get a CSS of about 11 milligrams per liter. If we give 350 milligrams Q12, then this changes to 700 milligrams a day, right? So 700 times 22 divided by 1200. So the X is 12.8. So that same thing we got before, about 13 milligrams per liter. So those are your choices, just like we said before. Okay, so we're going to either recommend 300 or 350 milligrams every 12 hours for our patient. Now the next part of the question is, how long do we hold the dose? This is a little trickier, isn't it? So if we know right now that we're at 22 milligrams per liter, and we want to know when it gets down to 12, because then we can start our drug again. We're holding the dose, so the drug is decaying, isn't it, if this is natural log concentration. So we want to know what this time difference is, don't we? This is a decay model, one compartment decay model, so we can use our good old CT is equal to C0 e to the negative KT. Right? So if that's the case, then we know that C0 here is 22, don't we? Milligrams per liter. And where we want to get to is 12 milligrams per liter. So our CT is 12 milligrams per liter. And the T here is going to be the time difference between those. That's what we're solving for here. What's our K going to be? Well, we just determined our clearance is equal to 2.27 liters per hour. And we're still guessing that the volume is about 50 liters. So what's our K going to be? It's going to be 2.27 divided by 50, right? If we, let's check our units. Liters cancel. It's going to be per hour. That's what we want, right? So 2.27 divided by 50. So our K is going to be 0.045. You can put the other 4 on there if you want, per hour. Okay, so then we need to come in here and solve. Oops, erase. Our K is going to be 0.045 per hour. And now we're solving for T. Do you all know how to do the algebra to do this? First thing I do, this is also milligrams per liter. So 12 divided, so bring 22 over. So we have to divide by 22. So 12 divided by 22 is 0.545. This is milligrams per liter. equals e to the negative 0.045 times t. Now, how do we get rid of this e? Well, we natural log each side, don't we? So what's the natural log of 0.545? Okay, I'm going to have to erase some here because I'm running out of room. So the natural log is minus 0.06, oops, sorry, 0.606 equals minus 0.045 t per hour. Okay? So now we have to divide this side by minus 0.045, don't we, to get t. Divided by 0.045. Make sure it's the minus because it needs to be plus. Our time can't be in negative hours. So our t will be 13.47. So we're going to need to wait at least 13.5 hours to start it again. So I might round that to 12 just because that's a more reasonable number, but you're going to need about 13.5. If I ask you on an exam, do the exact number, or if I ask you what you would round it to, I would round that to 12. So I would hold it for 12 hours and then start your Q12 either 300 or 350 every 12 hours of theophylline. Okay? That's it for this one.